So, good day everyone. We are the group assigned of presenting Chapter 6 called Cloud Platform Architecture. So, in this session, we'll quickly cover cloud computing models, data center design, compute and storage cloud architecture, and explore public cloud platforms like GAE, AWS, and Azure. We'll also touch on intercloud resource management and crucial cloud security. So, let us begin.
Today, I'll be discussing the Chapter 6 topic Cloud Computing and Service Model. So, what is cloud computing? Cloud computing means using the internet to access services like data storage, servers, databases, and software. Instead of relying on your local device, this saves time, space, and money. Most apps we use today, like Gmail or Google Drive, are cloud based. And cloud computing works through two major models. The first one is deployment models, and the second is service models. So, deployment models, this defines where the cloud is located and who control it. And there are four types. The first one is public cloud. This shared resources over the internet and cost-effective but with basic security. Example is Gmail and Dropbox. The second is private cloud. Exclusive access for one organizations offers better security. Next is hybrid cloud. This combines public and private clouds. Sensitive data stays private and less sensitive tasks go public. And last is community cloud. This shared by organizations with similar needs. Example is government agencies sharing a cloud for joint project. Next, service models. This refers to what type of cloud service are offered. The first one is IaaS or Infrastructure as a Service. This gives access to computing resources like servers and storage. Next is PaaS or Platform as a Service. Offers a development platform for building apps without managing hardware. Example is Google App Engine. And the last one is SaaS or Software as a Service. These users access software online without installing it. The example for this is the Microsoft Office 365.
Data center designs and interconnection networks. First, let's talk about data center design. It refers to the planning, architecture, and infrastructure setup of a facility used to house computer systems and associated components. The examples of data center design is servers, storage systems, network equipment, power supplies, cooling systems, physical security, and mechanism. And these are the types of data center design. First is enterprise data centers. Second, colocation data centers. Third is cloud data centers. Fourth, hyperscale data centers. And the fifth is modular data centers. And for the brief history of the center design, it is designed and evolved significantly from the large, power-hungry, and space-intensive rooms of the mid of 20th century. And data center design from 2020 to the present has been characterized by a shift towards modular, flexible, and sustainable designs driven by the increasing demand for cloud computing, AI, and 5G. And for next is the interconnection networks. It is the systems that link various networks or network components together, enabling communication and data exchange between them. They are crucial for creating larger, more efficient network systems and are found in diverse applications like computer systems, telecommunications, and data centers. Examples of interconnection networks are computer systems, telecommunications, data centers, and yan. And the key aspects of interconnection networks are connecting disparate interconnection facility and components of interconnection networks involves processor and memory of computer systems. And, and this is the brief. Next is the brief history of interconnection networks. Early 1960s to 1970s is early supercomputers like CDC 6600 use crossbar switches to connect multiple processors and memory units. And for the 1980s to 1990s is used in parallel computing systems such as in Intel IPSC, Hypercube, Ncube, and Thinking Machines CM-5. And for the 2000s to presents, history is inspired by telephone network designs. FAT3 was adapted for scalable data centers network by researchers like Charles Close and Google engineers. Thank you.
So, architectural design of compute and storage cloud. So, what is cloud architecture? It is the structure and design of cloud systems. It includes all the components needed to deliver services like storing data and running applications over the internet. So, these components work together to make cloud services fast, reliable, secure, and scalable. So, example of this is Compute Cloud. Provides virtual computers to run apps. And then next is Storage Cloud. Stores files like photos, videos, or document online. So, what are the types of cloud deployment models? So, these are ways cloud services are delivered to users or organizations. Each type has different levels of privacy, control, and cost. So, first type is deployment model. So, we have public cloud, private cloud, hybrid cloud, multi-cloud, community cloud. Next type is storage type. So, block storage, file storage, object storage, and then next is what is the supporting technologies. So first, virtualization. So virtualization let one physical servers run many virtual machines and save cost and improve flexibility in the cloud. So example of this is AWS EC2 runs multiple VMs on one server. So next is distributed storage system. So it stores data across many servers, not just one, and increase speed, reliability, and access. Example of this is Google File System. So how cloud computing uses virtualization. So virtualization let one real server act like many virtual computers. Cloud providers use this to give each user their own virtual machine, and it helps save money, share resources, and run many apps at once.
Now let's talk about public cloud platforms. As what we have learned earlier, public cloud is a type of computing managed by third-party providers that offers resources and services to users or organizations around the globe. Some of the benefits of utilizing public clouds are the following: scalability, cost efficiency, faster deployment, reliability, and sustainability. Now, public cloud platforms refer to organizations that host and offer these public cloud services. There are several public cloud platforms, but this topic would only focus on these three: Google App Engine, Amazon Web Services, and Microsoft Azure. These three are considered the three big platforms for cloud computing today. First off, Google App Engine. It is a core service under Google Cloud Platform that offers platform as a service. Google App Engine focuses more on serverless application development. Its key features includes supporting use cases from serverless computing and web applications to integration with Internet of Things and artificial intelligence. Next, Amazon Web Services. It is currently the largest public cloud platform among the three, and it offers all three major cloud service models: IaaS, PaaS, and SaaS. Its key features include advanced capabilities in artificial intelligence, machine learning, data analytics, and scalable infrastructure solutions. Its common use cases include app and web hosting. Lastly, Microsoft Azure. Just like Amazon Web Services, it also offers all three major cloud models. Its key features include strong integration with Microsoft Enterprise tools and a broad range of services like databases and analytics. Its use cases include developing machine learning models and blockchain applications.
Good day, sir. I am BJD Guntayon. I will present the Intercloud Resource Management. And there are four types of intercloud resource management. First is the Federated Cloud Resource Management. A group of clouds collaborates under shared policies and agreements. Second is multi-cloud resource management. A cloud provides without direct interaction or integration between the clouds. Third is hybrid cloud resource management, combined public and private clouds with orchestration to move workload. Brokerage, a third-party broker to manage and negotiate from the cloud service to provide optimized cost, performance, and availability. Based on my research, there are 5 cases in real life. The first one is the disaster recovery. Workloads automatically shift to another cloud providers if one fails to ensuring business continuity. The second one is the cost optimization. Organizations switch between the cloud providers to minimize costs based on the pricing of the models and the usage pattern. Third is data sovereignty and compliance. Companies use a different clouds in different countries to comply with data protection in law. Load balancing. Workloads are distributed across multiple clouds to avoid overloading in any single provider and improve performance. Lastly, global service delivery. Applications are deployed across clouds in multiple geographic regions to reduce latency in users and for worldwide. And that's all.
Cloud security protects data applications and systems in cloud environments using policies, technologies, and controls. It prevents threats like data breaches, cyber attacks, and unauthorized access. Key tools include identity and access management or IAM, data encryption, network security firewalls, VPNs, and real-time threat monitoring SIEM. Trust management builds confidence between cloud providers and customers through reputation scores, compliance checks, and meeting regulations like GDPR and HIPAA. Further issues and challenges of cloud computing include security and privacy, downtime and availability, vendor lock-in, limited control, cost management, compliance and legal management, performance challenges, integration and data loss.
The design and delivery of contemporary computer environments heavily relies on cloud platform architecture. Fundamental elements of cloud computing are examined in this section, including public cloud platforms, service and deployment patterns, and the underlying technologies such as data centers and interconnection networks. Along with making sure students comprehend fundamental security and trust management procedures, it also explores the administration of cloud resources across several providers. Since cloud platforms power everything from personal apps to multinational corporations, this subject equips students with critical thinking skills and technical knowledge they need to interact with and navigate cloud-enabled systems.
I'm here to introduce you the people in charge with this video presentation. Our leader is Ramos Abigail Cyrene. She is one of the authors. The other authors are Alejandro Ralph Harvey, Tomines Altea, Daguro Mark Christian, Guntayon BJ, and Bautista Rosario. The next members are Taguba Frances Carrel, who is the module editor. Next is me, Dulatre Rafael Vinch, who is the PowerPoint maker. And lastly is Mamwad Braille Niel. Thank you for watching.